Welcome to Excel 2013 Statistical Analysis video number 25. Hey, if you want to download this Excel file and the PDF file that goes along with Chapter 4, click on the link below the video. Hey, I'm going to do something unusual. This will be the first time we're not using Excel. I have these handwritten notes. It's a PDF file that you can download. These are the notes just like I would write them on the board in class. Now, we're going to talk about the basics of probability. So I have some handwritten notes here, but then we'll go over to Excel and do a bunch of calculating. Now, probability. What is probability? Well, the synonyms for probability: chance, likelihood, possibility. Anytime you hear people use those words, we're talking about a number between 0 and 1. Greater than or equal to 0 or less than or equal to 1. It can never be anything above 1 or anything below 0. You know, tests and quizzes in this class, I get people, they give me minus numbers and huge numbers above 1. Just remind yourself, those are not probabilities. Because you think about it, if we're given a probability that something can happen, the biggest number it can ever be is I'm 100% sure it's going to happen. You can't have 110 and 0. There's a 0% chance that that event will occur. Those are the two bookends. 0 to 1 inclusive. Now, probability is a chance that something will occur in the unknown future. Now, even if we create a probability and we're pretty sure about it, it's still only an estimate. Our probability is never known with certainty. It's only an estimate. Now, we're going to talk a lot about probability, but we got to start with a bunch of terminology. How about random experiment? Random experiment. We're going to have 3 important points. The first, a process that generates well-defined outcomes. So for example, if you're tossing a coin, you either get heads or tails. There's no other possibility. Driving on a bridge and you're interested in traffic, you either get stuck in traffic or you don't get stuck. Rolling a die, there's only 6 possibilities. A product coming off of an assembly line, it's either defective or not defective. The next point, on any single repetition, one and only one of the possible experimental outcomes can occur. So if the product comes off the line, it's either defective or not defective. It has to be one of those. Third, the experimental outcome that occurs on any trial is determined solely by chance. So that's our random experiment. Now we're going to see a lot of experiments, but most of them are going to be multi-step. That just means more than one step, right? Rolling a die 2 times, flipping a coin 3 times, or driving across a bridge 7 times. And we want to know what's the probability of getting stuck in traffic: 0 or 1 or 3 times. So multi-step experiments. Now, when we do experiments, one of the basic building blocks of learning probability is the sample point. And we're going to do a lot of trying to figure out what all the sample points are when we run experiments. Sample point is simply one of the possible experimental outcomes. And these 2 words are synonyms: sample point, experimental outcomes. And the textbook in my notes in Excel and when I talk, I tend to use them interchangeably. I'll try to use sample point more than anything. Now, examples of a sample point. What if we flip a coin 1 time? Well, it's either head or tail. Sample point 1, head. Sample point 2, a tail. But when you start having multi-steps in your experiment, then it gets tricky sometimes. Sometimes it's impossible to list all the sample points. But let's look at this. Flip a coin 2 times. Well, one of the possibilities is we get head-head. Another possibility is we get head-tail. Still another is tail-head. And finally, the fourth one would be tail-tail. A lot of times, people will get these middle 2 mixed up, and they'll only count it as 1. Now, figuring out and listing all of the sample points, we'll do that on some small data sets. But for big data sets, it gets pretty difficult. We'll also see a method to determine how many actual sample points there are in a sample space. What's a sample space? Oh, sample space, it's a list of all the possible experimental outcomes. So for example, for our first just flipping a coin once, our S would be HT. Now what if we flip a coin 2 times? The sample space would be, well, head, 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 tail, tail, head, and tail, tail. Now sample points like this, when we do them, we're also going to calculate the probabilities for each one, which will help us figure out some of the tougher probability problems. Now our formula for counting is going to be pretty straightforward. Total number of experimental outcomes, sample points, right? We need to figure out all the sample points. It's just going to be outcomes on step 1, outcomes on step 2, all the way to the final step. K will be our number of steps, like flipping a coin twice, K would be 2. N1 would be 2 because we have 2 possible heads, tails. N number 2 would be heads, tail. Now, if the number of possible outcomes is the same each time, we can simply take whatever the number of outcomes raised to the total number of trials. Here's 2 examples. Flip a coin 3 times. Well, it's N 2, 2, 2. And why? Because we either get heads or tail, heads or tail, heads or tails. So 3 steps, multiply 2 times 2 times 2, we get 8. Or because N is the same each time, number of outcomes, we can simply go 2 to the 3rd. How about for rolling a die 2 times? Well, we have 6 possible outcomes. And then on the second roll, we have still 6 possible outcomes. So if K is 2, again, this is the same number of possibilities for each N. So we simply can say 6 raised to the K, which is 36. And we'll do both of these examples. Now, in our next video, we'll talk about combinations and permutations. So I'm going to skip over these. Now, listing all the sample points in the sample space, we have a couple ways we can do this. One is the tree diagram. So if our experiment is tossing a coin 3 times, well, we start with the first toss, head or tail. And then we go, when we get to this point right here, well, we can get head, tail. Then when we get to this point right here, head, tail. So only on this outside tail, 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 that tells us one of the sample points. Tail, tail, head, there's another sample point. Tail, head, tail, still another sample point. And then tail, head, head, that's a 4th sample point. So you continue this tree diagram, and you can list all of the sample points. You can also list all of the probabilities, and we will see how to do that. Another way to do this is the table format. Step 1, 2, 3 for our experiment. And then you have to methodically list head, 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 tail, etc. And we will actually do this one over in Excel. Now, our next example would be our rolling a dice. And notice we're going to use the table format here, list 1 to 6, 1 to 6, and then the intersection. You could also do this one vertically, but sometimes easier to list it like this. Now, the interesting thing about listing sample points is you're like, well, that's crazy, but check this out. What is 6 and 1? It's 7, right? What is 5 and 2? 7. Each one of these is a roll of rolling 2 die, right? 4, 3. So we get a 4 and a 3. We get a 3 and a 4. Each one of these adds up to 7. So here's the deal. In probability, if you want to know the probability of rolling a 7, you have to look at the sample points and count how many there are, 6, and divide by our 36. That will give us the probability of rolling a 7. Now, it's not always this easy, and we'll see some examples, like with conditional probability, where it's not straight counting and dividing by the count. But again, listing all of the sample points as you're learning probability is really helpful for understanding how probability works. Now, methods of assigning probability. 3 basic methods. The classical method, that's like flipping a coin or rolling the dice. All experimental outcomes are equally likely. That's the definition of our classical method. In that case, we can simply count the number of favorable sample points, like dice add up to 7, and divide by the total number. Another example here, if you get audited by a district office, well, that district office does 3 million tax returns, and they always audit 3,000. Well, if you know that, then you can simply do the straight division, and you get 1 out of 1,000. That's the probability that you're going to get audited using the classical method. Now, the next method, relative frequency, oh, we've already talked about this. That's doing our frequency distribution and then relative frequency with formulas or a pivot table from a data set. Those decimals or percentage are our relative frequencies. The idea of relative frequency is we use past data to predict the future. Now, the law of large numbers, which I kind of wrote sideways, so you have to turn your head off to the side here. Over a large number of trials, relative frequency will approach the true probability. And that sort of makes sense, right? If there was 1,000 in the population, the closer and closer your sample size gets to 1,000, the more your relative frequency method of estimating the probability gets to the true probability. The final method is the subjective method. And there's a couple ways you know that you're doing subjective, right? You can't realistically assume that all outcomes are equally likely. And there's little past data. Now, I'm actually shooting this on January 31st, 2015, which is the night before the Super Bowl between the Seahawks and the Patriots. Now, you think you could look at past data and figure out the probability, but I don't think so. I mean, think about it. Russell Wilson, quarterback for the Seahawks. Tom Brady, quarterback for the Patriots. The coaches, Carroll and Belichick, all the players. Well, wait a second. They've even played before, right? But all of the details were different the last time they play. The location that they're playing down in Arizona, it's all different. So there's really no past data. You can look at things that are parallel and try and estimate. But once you do that, you will be using the best information you have, but it will be your personal belief. All right, so we have classical, relative, and subjective. Now, a couple more important points before we jump over to Excel. Requirements for assigning probabilities. Guess what? Every probability is going to have to be between 0 and 1 inclusive. Oh, well, we already talked about that. But think about our relative frequencies, right? Each one of the individual items was between 0 and 1 inclusive. And all of them together had to add up to 1. And that's going to be true for every one of our situations when we're assigning probabilities. And we'll do a bunch, and every time we'll check, is each individual probability between 0 and 1? And are the totals of all those probabilities adding up to 1? Now, two last points. We have to learn what an event is and how to calculate the probability for an event. Now, an event is simply a collection of one or more sample points. Now, think about our dice example, right? We had to count how many 7s there were. That's a collection of one or more sample points. And the event was rolling a 7. Calculating the probability of event, well, we did that too. Remember, 6 divided by the 36 gave us the possibility of getting a 7 when we roll 2 dice. Let's scroll down here and look at another example. And we'll actually do this a bunch. Here's our experiment. Tossing a coin 3 times. 1, 2, 3. List all the sample points. And look at this, since it's classical, each sample point is simply 1/8 or 0.125. But if we're talking about events, the event of 2 tails in 3 flips, well, guess what? There's 3 sample points. If we're going to calculate the probability, what is the probability? We have to add up the probability for each sample point. Down here we have our sample points, 1, 2, 3. And here we have 0.125 plus 0.125 plus 0.125. And we get 0.375. So if you roll a pair of dice and you're expecting to get a 7, you can estimate using classical probability that the probability is 0.375. Now, I want to jump over to Excel and talk about all of the terms we just talked about and do some examples. Now, we're on the sheet all sample points. Here's our multi-step experiment. Flip a coin 3 times. K. That's the number of steps or trials. And so we're going to type a 3. Number of outcomes, well, it's either heads or tail for the first one. How about the second one? Oh, it's still heads and tails. How about the third one? That's heads and tails. They're not always the same, but in this case they are. So simply, the long method is simply to take n1, number of outcomes, times n2, number of outcomes, times n3, number of outcomes, and we get 8. Or, because each step has the same number of outcomes, we simply take one of these and raise it to the number of steps or trials, RK. So 8. All right, so I'm going to list 1 through 8. 1, 2, enter. Now watch this. I'm going to do a cool trick. I'm going to highlight 1 and 2, point to the fill handle, and when I see my angry rabbit, click and drag, and there I get 1 to 8. Now this is the hard part, right? Hey, well, step 1, step 2, step 3, we're going to have to list all the sample points. Well, I'm going to go head, head, head. That one's easy. Now I'm going to, since this is the only one with 3 heads, the next one is 2 heads. So I'm going to try head, head, and tail. OK, well, the tail is at the end. Now I'm going to put the tail in the middle, and then put a head here and a head here. Now there's a tail, a tail. So now I'm going to put a tail there, and then this will be head, head. All right. Well, OK, so we got 3 heads, 2 heads. Now this is 1. So I'm going to start off with 1, and then a tail, tail. OK, so I have a head in the beginning, so now I'm going to put a head in the middle. And then this one's a tail, and that one's a tail. And then head, head, so I'm going to put one at the very end. So that makes these tails. And the last one is simply tail, tail, tail. Now, if we're listing the sample space, and sometimes we'll have to do that all the way up through chapter 7 or 8, I think, when we do the central limit theorem, you can either type this out, h, comma, h, comma, h, or we can build a text formula. You don't have to do this, but I'm going to show you how to do this. Well, the first thing I want is I want the equal sign. And remember, we have a join operator, ampersand, and then I need to put the comma in double quotes, and I want a space. So I actually have in double quotes, comma, space. Now I need to join that to the next one. Boop. And I'm going to cheat. I'm going to copy this. I got that perfect setup. Copy, Control-C, and Control-V, and then I can click on the last one. And that'll work all the way down. And copy it down. That's perfectly fine. If you wanted to have the parentheses, and sometimes you want to do that, then you could put double quote, open parenthesis, double quote, and join. Notice how when the formula is not working, they all turn black, or everything after the error. And then at the end, I'm going to join and double quote, close parentheses, end double quote. Control-Enter, and copy it down. All right, so now we calculate the probability. Well, this is classical probability. So I'm simply going to say equals 1 divided by 8, F4. Control-Enter, and copy down. Later, we'll have examples where we're doing probability for sample points, and it will not be that. We'll have to do some tricky formulas with conditional formatting. All right, so now, hey, let's check out rule number 1. Are all of these between 1 and 0? Yes. So our first requirement for assigning probabilities, that has been met. Now, what about this? I'm going to Alt equals and enter. That equals 1. So requirement 1, each one of these is greater than or equal to 0 and less than or equal to 1. And then down here, the sum of them are 1. Now let's put this to use. I'm going to scroll down here, and we're going to try and calculate some probabilities. Hey, the first probability is, hey, what's a probability of 3 straight heads? Well, looking at our sample points, we can see there's only 1. So here I could just go 1 divided by 8, or I'm going to point up there and get that probability from the table. Remember, the definition of an event, well, there's the event, pull 3 straight heads, and there's the sum of all the sample points. Now I'm going to list the sample point right here, because again, we want to emphasize that probabilities of events are finding all the sample points, the probabilities, and then adding them. Now, what about our next one? Probability of 2 tails and 3 tries. Well, I got to go up to my sample points. It looks like tail, 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 and tail, tail. So these 3 right here, I'm actually going to list these first. Ready? Equals, hey, there's a head, tail, tail. Tab equals tail, head, tail. Tab equals tail, tail, head. Boom, there's our 3 sample points. Now I'm going to add the probability for those sample points. Alt equals, and enter. Now again, for classical, we could count and divide by the count, but we're emphasizing because later we're going to, as we're learning, try on the tricky ones to figure out the probabilities for each sample point and then add them. All right, our last probability, probability of 1 tail and 3 tries. Well, that's up here. There's 1 tail, 1 tail, 1 tail. So these 3 right here. I'm going to list all the sample points. Head, head, tail, tab equals head, tail, head, tab equals tail, head, head, tab. Each one of those has 1 tail. And we're going to alt equals, the definition of probability is to add up the probabilities for those sample points. And there they are, enter. Now we want to go from this example. Here we're adding up sample points. But in a situation like this, we can actually find all of the 2s, right? 2 tails and 3 tries. We can actually find all of these probabilities and add them in a table. So let's go over to, RF table. Sounds like a relative frequency table. Now notice what I did over here is here's the table we just built. But I went ahead and added a formula, COUNTIFs, and I'm counting the t's. That's a relative cell reference, right? So as I copy it down, it counts. So here's a list. Right next to our sample points and our sample point probability, we have the number of, and it's not heads, it's tails. We've defined a success up here as a tail. So that was the wrong label there. But 0, 1, 1, 1, 2, 2, 2, 3. So now let's come over. Here's our frequency table. Remember, the first column has a unique list, 3, 2, 1, 0. Now we count, then we calculate the probability. So frequency equals COUNTIFs. And the criteria range, that's this whole range right here. F4 to lock it, comma, 1 cell to my left. There's the criteria for counting. So 3, we better get a count of 1 when I copy this down. 3, 3, 1. Absolutely beautiful. Now when we add these frequencies up, Alt equals, we better get the total number of sample points. And sure enough, we do. We don't need to add, but now we need to calculate relative frequency. Equals, there's the frequency, just as we did in Chapter 2, divided by the count, F4. Control-Enter. Each one of these better be between 0 and 1 inclusive. They are. And when we add them up, Alt equals, that better be equal to 1. Both requirements are looking good. Now we have our probabilities here. And when we come and ask a question, pull 3 straight heads, we can simply say equals, well, there's the probability for pulling 3 straight heads. Probability of 2 tails and 3 tries equals, I just click on, there's the 2. We've already added them up. Boom. Probability of 1 tail and 3 tries, there it is. Next chapter, we'll see this is a random variable, and we'll call it x. There it is. So equals, there's the probability associated with this event, and enter. Now we want to go look at our third example on all SP2. Now on this sheet, we want to try to list all the sample points for the experiment rolling 2 die. Now, we're going to have the dice in our hand and throw them at the same time, but it'll really be one and then the other. That means there will be 2 steps or trials, 6 sides on each die. That means there's 36 total sample points. We simply took 6 squared. Now, I want to list all the sample points. And it seems like a lot, but we'll see some cool tricks to make this go quickly. The first one is, and we saw this last example, 1, enter, 2, enter. And I'm going to highlight both. And notice when I point to that fill handle and my selection cursor turns to an angry rabbit, click and drag. Now notice what this does. This increments the numbers. It's called a series. We're adding by 1, so we get all the way to 36. Now, if we're going to list all of the sample points, we need a 1, 1, 2, 1, 3, 1, etc. So over here, I'm going to do 1, 2, highlight, and I'm only going to copy it to 6. Now, notice it's incrementing, but watch this. Since I want to repeat 1 to 6, 1 to 6, 1 to 6 many times, double click and send it down because there's something to the left that goes all the way down. But it's doing a series. It's incrementing the numbers. But watch this little smart tag. I'm going to click on it, that little arrow, and say copy the cells instead of the default fill series. So copy 1 to 6, 1 to 6. That's a pretty cool trick. Now watch this. We're going to do another trick. Highlight, and I'm highlighting all 6 next to 1 to 6. That active cell, I'm going to type a 1. Now notice it's in edit mode, and I put something in the active cell. If I Control Enter, it'll populate all the way down. Control Enter. Now I can come down, highlight the next 6, 2, Control Enter. The next 6, 3, Control Enter. The next 6, the active cell, I type a 4, Control Enter. 5, Control Enter. 6, Control Enter. That's pretty cool. That was fast. It seemed like 36 sample points would be a lot, but we did it quickly. Now, I definitely want to list the sample points, and we're going to do just like we did before. Our text equal sign, double quote, open parentheses, double quote, and I'm going to join that to this 1. Control Enter and double click and send it down. You can see that gives us just those 2 things joined. F2, I need to join it in double quotes, comma, space, end double quote, and join it with the next row. And finally, I need to join it ampersand, double quotes, and I need a parentheses, end double quote. Control Enter, double click and send it down. That is pretty cool. That's a lot faster than doing it by hand. By the way, not only is it faster doing it by hand, but you're going to avoid errors. Inevitably, if you have to type all this out, you get some errors. That's why even over here, having some tricks to enter that data was very helpful. Now we want our probability. Hey, this is a classical example. Each one of these is 1. We simply take 1 divided by 36, and that gives us the probability for each sample point. Equals 1 divided by 36, and I'm going to F4. Control Enter. Double click and send it down. Now, if we're going to ask probability questions about the sum of these, let's just add them up. Alt equals, it guesses wrong, but the dancing ants are moving, so we simply redirect it. Those are 2 relative cell references. Control Enter, double click and send it down. Any cell, F2, you see, it works perfectly. That's pretty cool. And look at that, 2, 3, 4, 7. All the way down. Now, it looks like there's only going to be 1, 2, and 1, 12, but all the rest of them will have some repeats like 3, 3. Hey, look, that's snake eyes, 1, 1. You only get 1 snake eyes. Now we can do our probability. Hey, what's the probability of summing to 2? It's simply 1 sample point. There's the probability. Tab, I'm going to come over here and list the sample point. All right, that's pretty cool. Now, how about the probability of getting a 4, meaning the sum of 4? Well, let's see. There's a 4, a 4, a 4 down here. Whoa, so then there's no more down there. So watch this. I'm going to list them. Equals, there's the sample point. Tab, equals, I've got to be careful here. I'm doing this manually, right? Tab, equals, and I'm scrolling down. There it is right there. Tab. Now, why are we belaboring all this? Because really, listing sample points, getting the sum, the total, is really going to help us throughout this chapter, next chapter, and it will be the foundation of the understanding of probability for the rest of our chapters. Hey, I'm going to add them up. Equals, boop, plus, and there's a 4 here, plus. And I know these are all the same, but I'm getting the idea. I'm adding these different, and later they won't be the same. We'll see some examples with conditional probability. Hey, there we go, 0.083. So 8 1/3%. Now 11. 11's way down at the bottom. I'm going to say equals and scroll all the way down. I'm looking for 11's. It looks like there's 1, 2. So just, I'm going to get that sample point, tab, equal, and scroll down, tab. All right, and so then adding them equals, scroll all the way down. So there's the 11. There's the probability. And I'm going to type a plus. You can see it coming up in the formula bar. And then there's a plus right there. And enter. So there we have listed all of the sample points for rolling 2 die. We actually added them all up. And then we saw, again, that when we have an event like the sum of 2 or the sum of 4, oftentimes we're having to list multiple sample points and then add up the probabilities. All right, so for this video, we talked about the basics of probability. And most importantly, we talked about sample points and creating a sample space, getting the probabilities. We talked about events and getting the probability for events, which means finding the sample points, adding up the probabilities. Next video, we'll talk about combinations and permutations. And then after that, we'll continue our study of calculating probabilities for events. All right, we'll see you next video.